Welcome to Spring LIB.
In this exercise, we're going to be dealing with the concepts of force and acceleration. So before diving into our problem, I'm going to briefly review these concepts. So remember that according to Newton's second law, we have that the sum of all the forces in a body, which we call the net force, is equal to the mass of the body times the acceleration. Also remember that the acceleration is the first derivative of the velocity with respect to time, or the second derivative of the position with respect to time. Okay, so this is all we need in order to solve our problem. In our problem, we have a parachutist that has a mass m, and he opens his parachute initially with a speed v0 of 0, and the drag resistance force that the air exerts on the parachute is equal to k is a certain constant, times v squared, where v is the speed of the parachutist at a given moment. And our goal, given this information, is to find what is the speed v of the parachutist as a function of time t. So remember that the force is equal to ma, so kv squared, actually the net force is equal to ma, and the net force on the parachutist is kv squared minus mg. Okay. Actually, I'm sorry, I'm going to use a different convention here. I'm going to consider that this here is the parachutist. The positive direction is downwards. And notice that the force, the resistance force, acts upwards, while the gravitational force acts downwards. So we have Fr, which is kv squared, or better, the weight force, which is mg minus kv squared, is equal to ma. Now a is dv dt. So we have mg minus kv squared is equal to m dv dt. So we have that dt is equal to m divided by mg minus kv squared dv. So we have that dt is equal to m divided by k times dv divided by mg over k minus v squared. And now we can integrate both sides in order to obtain v as a function of time. Now, this integral is a little tricky to perform, so let me walk you through it. We have that 1 over m g over k minus v squared is equal to 1 over mg over k, actually the square root of mg over k minus v times the square root of mg over k plus v. Okay, and I'm going to try to write it as a divided by the square root of mg over k minus v plus b divided by the square root of mg over k plus v. And you can check that this equation has a solution if a equals b equals 1 over 2 times the square root of k over mg. Okay. So we have that the integral from 0 to v of dv divided by mg over k minus v squared is equal to the integral from 0 to v of dv times 1/2 times the square root of k over mg divided by the square root of mg k minus v plus the integral from 0 to v 1/2 the square root of k over mg dv divided by the square root of mg over k plus v. So we have 1/2 k over mg times the logarithm of, actually minus the logarithm of mg over k minus v from 0 to v plus the logarithm of the square root of mg over k plus v from 0 to v. Okay, so then notice that this is equal to 1/2 of the square root of k over mg times the logarithm of the square root of mg over k plus v divided by the square root of mg over k minus v. Okay. So now we can go back to our equation, this one here. So we have on the left hand side we have t, and on the right hand side we have m over k times the integral we just found, so that's 1/2 of the square root of k over mg times ln of the square root of mg over k plus v divided by the square root of mg over k minus v. So we have t is equal to 1/2 of the square root of m divided by kg ln of the square root of mg over k plus v divided by the square root of mg over k minus v. So we have 2t times the square root of kg over m is equal to ln of the square root of mg over k plus v divided by the square root of mg over k minus v. So we have the exponential of 2t times the square root of kg over m is equal to the square root of mg over k plus v divided by mg over k minus v. So you can multiply both sides by the square root of mg over k minus v. So we have v times 1 plus the exponential of 2t times the square root of kg over m is equal to the square root of mg over k times the exponential of 2g times the square root of kg over m minus 1. So the speed v as a function of time is the square root of mgk times the exponential of 2t times the square root of kg over m minus 1 divided by e, the 2t times the square root of kg over m plus 1. So this is the first answer. Then we need to find what is the speed with which the parachutist hits the ground, and that speed must be taken by making t go to infinity. So we have that v of t going to infinity is equal to the square root of mg divided by k. And notice that this ratio here, as t tends to infinity, the minus 1 or plus 1 will not matter, so this will go to 1. So the limit is just the square root of mg divided by k, which concludes our exercise.